Hello everyone, hello lovely students, welcome back to this video session. Hope you all are doing great in your life. My name is Ashwant and I'm from India, which happens to be a very awesome, wonderful country. And today I have got a really exciting math lesson for you all. Want to know what's that? Then please don't skip and make sure to stay with me all around till the end. Here we go. So we have got these two questions for today's session and we have to find the domain for these questions. And I request you all to pause the video, read these questions carefully and try to solve them on your own. Alright, now let's solve these questions with me. And before we get into solving these questions, I would like to say a few concepts of the modulus function. Let's say we are given an inequality modulus of x greater than 5. And we have to get the values of x that satisfy this inequality. And so for this purpose we draw the number line. We have this number line that is running from negative infinity till positive infinity, and we mark some important numbers with respect to this inequality. So we mark 0, positive 5 on the right of 0 and negative 5 on the left of 0. Now we try to search some values of x from this number line so that if we put in this inequality, our inequality is satisfied and those values of x will be the solution for this inequality, right? Let's do that. So we have this number line and we try to find out some values of x. So let's suppose you try to find out some value from this interval, negative 5 to positive 5. This interval I'm talking about, this interval. So if we take any value of x from this interval, negative 5 to positive 5, and we will verify what's happening here. So let's suppose we take negative 4 and positive 4 and we see what's happening here. So if we take negative 4 or if we take positive 4, so the modulus of negative 4 will be positive 4 only. As we all know, modulus is an absolute value function. It gives a positive output, and here as well we have positive 4. You can see here both the inequalities are not satisfied. So this is a wrong and this one is also wrong. What I mean to say here is if you take any value of x from this interval, negative 5 to positive 5, it will not satisfy the inequality. So we reject this interval as a solution. We cannot take this interval for our inequality. Alright. Now let's try to find the values of x from the other interval that we are left with. So we are left with negative infinity to negative 5 and 5 till positive infinity. Now if you take any value of x from this interval and just verify what's happening here. So let's suppose we take negative 6 and we take positive 6 and we verify what's happening here. So when you take negative 6 and positive 6, you will find that the inequality is satisfied. So we can conclude from our discussion. Just right now we are doing this discussion and I'm using green pen. So if you take any value of x from the interval negative infinity to negative 5, let me erase this so that you may not get confused. So if you take any value of x from this interval, negative infinity to negative 5, and from 5 to positive infinity, your inequality is satisfied. You can take other numbers as well for verifying. And you cannot take negative 5 and positive 5. You have to be careful with that. Because if you take negative 5 or you take positive 5, so you get 5 greater than 5, 5 greater than 5 for both this one as well as this one, which is a wrong statement because 5 is equals to 5. So the final solution for this inequality is we can write x should belong to negative infinity to negative 5 union 5 to positive infinity. Now I can generalize this result. So whenever I can generalize this result by saying whenever we have mod of x greater than a, where a is any positive real, we can directly write x as negative infinity to negative a union a to positive infinity. Now what if we have an equality sign here So if we have an equality sign, the only difference it will be that we'll have to where a is a positive real number. So the only difference will be we have to include negative a and positive a. So it will be negative infinity to negative a, and for including negative a, we have to use a square bracket instead of the round bracket. Union a to positive infinity. So this is the value of x if we have equality sign, and if you don't have the equality sign, then we have to write the value of x in this way. Now, what if it is given to us, let's suppose you are given mod of x is less than 7, and you have to get the values of x that satisfy this inequality. So for this purpose, let's draw the number line, and we'll follow the same working rule as we did for the previous one. The number line is running from negative infinity to positive infinity, and we mark some important numbers with respect to this inequality. So we mark 0, we mark positive 7, and we mark negative 7. Now we try to find some values of x from this number line that can satisfy this inequality. So we first of all try to get the values of x from the interval negative infinity to negative 7 and 7 to positive infinity. So I'm talking about this interval and this one. We are not taking negative 7, positive 7. You can directly observe if you put negative 7 and positive 7 in the inequality, its modulus will be 7, and 7 less than 7 is a wrong statement. So negative 7 and positive 7 will never satisfy this inequality. Now we are taking the extreme left interval and the extreme right interval of the number line, and we are verifying that if there is some number existing which can satisfy this inequality. So let's take negative 8 and positive 8 and see what's happening here. So we take negative 8 and put it in the inequality, and we take positive 8 as well and we put it in the inequality and see what's happening. So modulus of negative 8 will be 8, as modulus always gives you a positive output. So you can see here this is a wrong statement. 8 is never less than 7. So this is a wrong and this is a wrong as well. So if you take any number from this interval, the extreme left interval negative infinity to negative 7 and the extreme right interval 7 to positive infinity, you can take some more numbers and you can verify none of the numbers will satisfy this inequality. So we reject this interval. Now we are left with this interval only, negative 7 to positive 7. And we'll see what's happening here. So if you take any number from this interval, let's say we take negative 6 and we take positive 5, and we see what's happening. Negative 6 and we take positive 5 and we put in the inequality and we verify. So we see that our inequality is satisfied for any value of x that we have taken from this interval negative 7 to positive 7. So the solution for this inequality, we can write x belonging to negative 7 to positive 7, an open interval, because we don't have an equality sign. If an equality sign is given here, like if it were given mod of x less than equals to 7, then we would have written x belonging to close minus 7 to close 7. Hope you understand. Now let's generalize what we just talked about. So whenever we are given mod of x less than a, so that will imply x belonging to negative a to positive a, and a is any positive real number. Just let me write. A is a positive real number. Now if we have an inequality sign here, so we simply will have to include negative a and positive a in our solution. A is a positive real number. So So these are the properties of modulus function that we're going to use for solving the questions of today's session. Alright, now let's get back to our questions which we are supposed to solve for today's session. So the first question that we have is f of x is equals to square root of mod of x minus 3, and we have to find the domain. So you all must be knowing, whenever we come across a square root function, that means some expression is written inside the square root sign and we have to find the domain. Then in order to define or to find the domain of such type of expression, we have to make sure that whatever is written inside the square root sign, it has to be either positive or 0. So for the first one, we have to make sure that mod of x minus 3, it is the inside quantity of the square root sign. It must be either greater than or equals to 0. Now we solve this inequality. We take negative 3 to the right hand side, so we get mod of x greater than or equals to 3. Now, just a couple of seconds back, I was talking about this type of situation, So it is quite and very much similar to mod of x greater than or equals to a, and a is a positive real. Here 3 is a positive real. So we can directly write x belonging to negative infinity to negative 3 union 3 to close infinity. That's all. So for the first question, we have got the domain. Now let's come to the second question. Second question, again we have a square root sign. This is the solution of first one, and now we are going to solve our second question. So for the second question, we have something written inside the square root sign. We have 7 minus mod x. Again, we have to make sure that this inner quantity, the inner mathematical quantity that is written inside the square root sign, it is either positive or equals to 0. So we have 7 minus mod x greater than or equals to 0. We simplify this and we get the value of x, that will be the domain. So we solve, we get 7 greater than or equals to mod x. In other words, we can write mod of x less than or equals to 7. And again, it is very much similar to mod of x less than or equals to a. And we all know that whenever we come across mod of x less than or equals to a, we write x belonging to negative a to positive a, where a is a positive real. So 7 here, it is functioning as a, so it's a positive real number, so we can directly write x belonging to negative 7 to positive 7. And that's all for today's session. So this was all about today's session, and I did my best to make you all feel comfortable and happy. If you like my video, then please share it to your friends and loved ones, and make sure to subscribe my channel and hit the bell icon to get the notification of my next upcoming videos. See you all, my lovely friends, in my next upcoming videos with more exciting, a lot of awesome questions. Till then, bye bye, stay safe and have a nice day.